Welcome. In this video, we will learn about face detection in the image. Here we will find the faces of person using OpenCV library in an image. So first, let's open my directory which contain my files. Let's open face cascade.xml. We have to use cascade classifier class to detect objects in an image stream. Particularly, we will use the functions to load .xml classifier file. It can be LBP classifier detect multiscale to perform the detection. So here is extracted directory which will access all the faces and store it in this directory. Now let's open the image. This is a group photo of astronauts. First, let's see the output. Let's open the terminal. Run the command as python space detect face.py. You can see that it will display an error message for accepting the image name. Now let's run the command again by passing the image name. That is a group photo of astronauts. Here it's image displaying, detecting all the faces present in the image. If I open here extracted folder, you can see one by one image has been cropped, and I can open and see each and every image. So in this way, one can detect and extract faces from an image. So now let's see the coding part. Let's open detect face.py. The first one is from random import randint. This module implements pseudo random number generator for various distributions. Import CV2, we know it. Import SYS, we are familiar with it. The new one is import OS. This module provides a portable way of using operating system dependent functionality. Now let's import the classifier, that is XML file which I had already shown. Cascade equals to face underscore cascade.xml. Now let's create the face cascade object called cascade classifier for object. Face cascade equals to cv2.cascade classifier cascade. Now let's define the function detect, that is define detect underscore faces image underscore path. Now we have to read the image here and convert it grayscale as we always do in all object detection programs. Image equals to cv2 I am read image path. Image gray equals to cv2.cvt color image cv2.color bgr to gray. Now let's detect the object of different sizes in the input image. The detected objects are returned as a list of rectangles. So faces equals to face cascade, detect multiple scale, image gray, scale factor equals to 1.16, minimum neighbors equals to 5, minimum size 25, flags equals to 0. Now let's iterate all faces here. So for that, I'll write for xy width height in faces. So now let's write the snippet which displays the extracted faces calculated and put in a rectangle to 8. For that, subject image equals to image y minus 10 x plus h plus 10 x minus 10 x plus w plus 10 OSCH directory extracted cv2 and write str randint 0 10,000.jpg sub image os.ch directory cv2.rectangle image x comma y x plus w y plus h 255 0 2. So this snippet displays the extracted faces calculated and put in a rectangle to 8. If the faces are found correctly, then print it on the windows and destroy all other windows. So cv2.imshow faces found, image. If cv2.wait key and so on. At the end, destroy all windows. So next, let's define the main function here. If name equals to main, create a new directory called extracted, which you saw there was one folder. So if not, extract it in os.list directory, os.mkdir, extract it. The argument should not be less than, otherwise it prints the error message. If length sys.argv, print usage python detect underscore face.py image path system.exit. So basically the argument should not be less than, otherwise print the error message. Now the detect face function will be called here and image name passed to the argument, that is detect underscore faces system.argv. So this is the program. We did detection of faces and cropped those faces and saved in extracted folder. Now let's see the output again. Let's open the terminal, run the command as python space detect underscore face.py. You can see that it will display an error message for accepting the image name. Now let's run the command again by passing the image name. You can see that image is displayed, detecting all the faces present in the image. Let's open my extracted folder. You can see here one by one image has been cropped and saved. You can open individual cropped photo and see it. So in this way you can detect faces and extract faces from the image. So that's it in this video on face detection in an image. Thank you for watching this video.